Hello everyone, today we'll see about Euclid's division lemma and prime factorization method. What he has said is, for any given positive integers a and b, say for example we have two positive integers a and b. What are positive integers? 1, 0, 1, 2, 3 up to infinity, and minus 1, minus 2, minus 3 up to infinity. These counts integers. So what are positive integers? These are the positive integers. These can be said as the positive integers. So for any given positive integers ranging starting from 1 and till infinity, any two numbers a and b, there exist two unique integers q and r. There are two integers q and r which satisfies the condition a equals bq plus r. Say for example we have to take HCF for 7 and we'll take HCF for the numbers 17 and 25. Okay, we'll assume a smaller number. So A will constitute this bigger number, A will have this bigger number and B will have this smaller number. So A equals, if we substitute this in this equation, 25 equals B is 17 into Q is the quotient and R is going to be the remainder what we get from dividing these two numbers, these two positive numbers. We'll divide these two numbers. I am using this as a rough column, this part as a rough column. So I am dividing 25 by 17. What will I get? What will be my remainder? 8 is going to be my remainder. Note this is the quotient and this is the remainder. Okay. Dividend and the divisor we have given already. So the quotient will come here. Q for quotient, Q stands for quotient will come here, and R stands for remainder and the remainder will come here. Now what we have to do is, this will be A and this will be B. So this is the larger number and this is going to be the smaller number. So 8 into how many times of 8 plus what will be the remainder. If I divide 17 by 8 now, 2 times of 16 and the remainder is going to be 1. So again, now this is Q and this is R. So I have 1 here. Again if I take, it is going to be 8 and 1. So 8 equals 1 into 8 times plus 0. So what can be the HCF? This can be the HCF. Because I have got till 1 and I have got the remainder as 0 as well. So this can be the HCF. Now we'll try the same with prime factorization method. We'll try to solve it with prime factorization method. If you want to take a note, you can take. We'll solve few more sums and few more examples to make the idea clear. And I have 25. 17 is a prime number. So a prime number is divisible by 1 and itself. So 17, 1, and I have 25 here. 5, 1, 5, 5, 1 and 1. So 17, 5 and 5. We got the answer as 5. So by prime factorization we got the highest common factor as 5. This is the highest common factor we got by this method. Now we'll solve few sums for both Euclid's division lemma, what he said, and according to prime factorization method. We'll go with few practice sums. Say for example, I have 90 and 30. Okay, let's try to solve by both Euclid's pattern and prime factorization method. So by Euclid's division, we have A equals BQ plus R, where Q stands for quotient, R stands for remainder, A is this number and B is the smaller number. So 90 equals 13 into how many times of 13? What quotient we have and what remainder we have. Let's try to divide. If I divide this, I am solving here, I am taking here 90, if I try to solve by 13 6 times give me what? 78. So what is my remainder here? 12. Now this is the quotient and this is the remainder. Again 13 and 12. 13, 12, 1 times of 12 plus the remainder is going to be 1. That is 13, 12, 1 times 1. This is what I have written. Again when I take 12, it will be 1. 12 times of 1 plus 0. So now I got the remainder as 0. And the HCF, what I am concluding is 12. Let's try to have this by another method, prime factorization method. Here I am taking it for prime factorization method. 90 and 13. 13 is a prime number, so it is divisible by 1 and itself. And next what I am taking is 2. 2 is a prime number. 45. 45 and 1. 5 is a prime number. 9 and 1. Again 3 is a prime number. 3 and 1. 3. So I have got these as the factors. 13, 2, 5, 3, 3. What is my repetitive factor here? What is the highest common factor? This has repeated 2 times 3. So I am taking here the HCF as 3. Because this has repeated 2 times. So I am taking HCF as, I am concluding HCF of 3. 3 is the highest common multiple which we got from this. Let's move let's take another example also. Let's take an exercise sum. What is given? First sum I am taking. I am taking the first exercise sum. What is given in the NCERT book? That is, I am taking the first sum. What is given in NCERT? 135 and 225. Let's try to solve. 135 and 225. Now I am trying to solve this by Euclid's division pattern. That is BQ plus R. A is the greater number. We can say A comes first, B comes next. So you can remember like this. A is the greater number and B will have the smaller number. Q for quotient we know, R for remainder. So it will be easy for you to remember like this. 225 equals 135 into how many times of quotient gives this remainder. I am dividing it this side. If I take 225 and 135, 1 time 135, I am subtracting this. This gives me 0. This gives me 9. This is my remainder and this is the quotient. So I am going to write the quotient as 1 and the remainder is 90. Now I am going to take this as the A and 90 as B, that is the smaller number. Now what quotient will I get again? 1 times of quotient, because when you divide 135 and 90, and when I am dividing I will get 45. So plus 45, this is my remainder. This is R and this is Q. Okay, so this is again now A and this is B. 90 equals 45 into 2 times gives me 90 plus 0. So I got the remainder as 0. Now what will I conclude as my highest common factor? Here I got 0. So this is my highest common factor. That is my highest common factor I've got is 45. When you solve this by prime factorization method, you may get a different answer. Today I have made you understand one concept clearly, that is Euclid's division pattern. If there is any doubts regarding this, do post in the comment section. If you have any doubts regarding real numbers, positive integers, negative integers, whole numbers, I have given it on another video. I have given in the description box. You can check if you need it. Thank you.